So we're gonna talk some more about conditional probability and Venn diagrams. I believe this might be an example from the book, example 4. I'm not sure whether you're given the Venn diagram or it's described, but I'm going to give you the Venn diagram in this case. If this is E and this is F, and I believe for this example, E intersect F is 0.6, F here is 0.2, so total 0.8 for the F and total 0.7 for the E, and that leaves that as 0.1. Total inside the circles is 0.9, so we also have 0.1 for that, right? Now, we could do our basic probabilities like probability of E intersect F bar, what's the probability something's in E but not in F, and that's 0.1, etc., right? But we can also do our conditional probabilities. What's the probability of E given F, right? So in that case, there's no real avoiding doing things with probabilities. You can't really avoid that. You can't go straight to counting, right? So we're going to use the formula. The probability of E given F is the probability of E intersect F divided by the probability of F. Although technically when I talk about it, I'm not going to talk in terms of formula, I'm going to talk in terms of situations. You restrict yourself to the F, so we should only be looking at the F's. So what do we have? The F's are all inside the F circle. What's the total inside the F circle? 0.8, right? On the other hand, the numerator should be only those F's that are also E. How many of these F's are also in the E circle? And that's 0.6. So 6 over 8, or if you prefer, 3 over 4, right? I don't think I mind reducing them as much when they don't refer to counts. So 3 and a 4. Restrict yourself to the F and then look for these that are inside the F. Or, what if I said, what's the probability of E given F bar? So we're only looking at the F bar. What's outside F? Well, this and this, 0.1 and 0.1. So 0.2 is outside F. And of those 0.2, how many are E? Well, this one right here is an E. So that's 0.1 divided by 0.2, which is 1/2. Or let's crank out a few more. What's the probability of F given E bar? Probability of F given E bar. So how many outside that E circle? Well, that's going to be, this is outside the E circle, and so is this, 0.3. And of those 0.3, how many are F? Well, 0.2. So this is 2/3. Probably F given E bar. So if you've got that Venn diagram, then recognizing which areas are which is really a good way to do these conditional probabilities. I think I'll do one more example starting from scratch instead of starting from the Venn diagram, just so we can see this one more time, work with it a little bit. Okay. Suppose I told you that the probability of A equals 0.37, and the probability of B equals 0.28, and the probability of A intersect B bar, stuff that's in A but not B, is let's say 0.13. I think that should work. Yep, that'll work. And find, let's say the probability of A given B, just as an example to start us out. Well, this is something that just screams Venn diagram, hopefully, to you, for many different reasons. So this will be our A circle, and this will be our B circle. And what do we know? Well, we need two identifiers to fill in an area, something that's in A and not in B. This is 0.13. Now the total inside the A circle has got to be 0.37. That means this part is 0.24. For a total of 0.37, you subtract to get that. And the B, if this is 0.24, then that part is 0.04. Let's see, that's a total inside the circles for 0.28 and this 3141 and 0.59 outside the circle. So let's do a few conditional probabilities. The probability of A given B, the denominator is the B's, right? So that is 0.28. And the numerator should just be those that are inside A, so that's 0.24. So this is 24 over 28. You're always discouraged from mixing decimals and fractions in your answers because that's kind of a bad form, it's extra confusing. So get rid of those decimals or plug it into your calculator and get only a decimal. What's the probability of B given A bar, let's say? So what's not in A, well, you can do it from here, A bar is 0.63, or you can do it from here, A bar is 0.04 and 0.9, but it's 0.63 in either case. 0.63, and of those that aren't in A, how many are in B? So these were our two that weren't in A, and this one is in B, so that's 0.04. So that's 4 over 63. Maybe one more. What's the probability of A given B bar? So our denominator is what's outside B. 0.59 and 0.13 is 0.72. You can also get that by taking 1 minus 0.28, of course. And of those, 0.59, 0.13, which ones are in A? And that is our 0.13. So that's 13 over 72. If I said A bar given B bar, we'd be looking at 59 over 72 because we'd be looking at the one that's not in A either. Yeah, which is for the heck of it, we'll write that down. Probability of A bar given B bar is 0.59 over 0.72 because these are the B bars, and of those B bars, which one are not in A, that's these. And so that's 59 over 72. So a combination of, you can do the formulas or you can just kind of count in terms of counting probabilities. So these are, they can get pretty tricky with the condition probabilities and the Venn diagrams, and you want to practice those especially. Okay, thank you.